All right, this is determining the rate law of a reaction. The reaction of interest is acetone going to products. It doesn't matter what the products are, it's just some reactant going to products. We have two trials that are being run where we change the concentration of acetone and the initial rate of reaction is measured. So the first question is to use the initial rate data to determine the rate law. The rate law is that the rate is equal to K times the concentration of acetone raised to some power. What we're trying to do is determine what this value of M is. We've applied the rate law to each of these trials. The rate of trial 2 is going to be equal to K times the concentration of acetone in trial 2 raised to the M power. And the rate of trial 1 is going to be K times the concentration of A of trial 1, also raised to the M power. All right, so now we're going to look at the ratio of the two rates. Taking a ratio here allows us to cancel out the value of K. Since we have the concentrations of trial 1, trial 2, and we have the reaction rates as given to us up here, we now have one equation with one unknown. We simply need to solve for the value of M. Here we substituted in our values from the data up here. We have the initial concentration of acetone, trial 2 to trial 1, and the rates, trial 2 to trial 1. And now we've finished the problem. We've put these numbers into our calculator and got 1.5. These numbers also give us 1.5. So 1.5 is equal to 1.5 raised to the M power. We can tell by inspection that M has to be equal to 1. So our rate law is that the rate is equal to K times the acetone concentration. Or, in other words, the reaction is first order in A. Part B is asking us to calculate the numerical value of the specific rate constant. And so for part B, we want to calculate the numerical value of K, and we can use either trial to do that. Ideally, we would have created a graph using many different trials, and both to determine the rate order and to get the value of K. But here we only have two trials, two data points, so we need to do it this way. All right, from the rate law that we've determined in part A, we have the rate is equal to K times the acetone concentration raised to the first power. We can solve for K and again use the data from either of these trials to calculate the numerical value. All right, I chose to use trial A, so here we have the problem set up. This is the rate divided by the concentration of A in trial A. If we look at our units, we see liters cancel, units of moles cancel, and we have units of K of reciprocal seconds, which is what we would expect. And here we are with our final value for K. The final part of this problem is C, calculate the initial rate when the initial acetone concentration is given to us. All right, so here we have the experimentally determined rate law, and all we're going to do is plug in this initial concentration and we can get the initial rate of reaction. And here we are with the answer. We've input our value of K from before. We went back to the unrounded value to minimize rounding error. Here's the concentration we were given in moles per liter, and our final answer expressed with 2 sig figs and the appropriate units.